the next thing we're going to do is run through two examples. Example number 1, example number 2, and then the formula is given to you in between here. So the same formula is going to be used for both of these. So example number 1, we have n is equal to 42, x bar is equal to 86.5, standard deviation, the sample standard deviation is 12.6, and we're being asked to construct a 95% confidence interval. In each of these, we're being asked to construct a confidence interval, right? And in each of these, we're going to be using this formula. Our task is to find a confidence interval for the mean if the population standard deviation, if sigma is not known, then we need to use the sample standard deviation, that is our formula. So, in both of these cases, what this amounts to is we need to be able to find the table value. All right, so we need degrees of freedom, and we need the value for alpha. Well, in this case, first off, do we know the sample size is sufficiently large? Well, in this case, example number 1, the sample size is 42, that is greater than 30, so we have met the sufficiently large requirement. You must check to be sure the sample size is sufficiently large. Other than that, for our purposes, the problem cannot be done. You may have some goofball instructor asking you an exam question where if this information is given, and maybe it's a multiple choice question, and one of the choices might be there's not enough information given. If we were working a problem with n equal to 12, and if the statement, this is a normally distributed population, is not also given, then that problem cannot be done, and the appropriate response would be, not enough information is given. So you must check to ensure that the sample size requirement, the sufficiently large requirement, has been met. In this case, we have n greater than 30. This is sufficiently large, so now we're off to the races. Our degrees of freedom, n minus 1. So for our degrees of freedom, we're going to use 41. So in our table, we're in the 41 degrees of freedom row. Our value for alpha, if we have a 95% confidence interval, then we know what alpha is. Right? Alpha is 0.05. And we need, as the formula reminds us, we need alpha divided by 2. So alpha divided by 2 is 0.025. We're going to be in the 0.025 column and the 41 degrees of freedom row. So between those two pieces of information, we can find the table value. All right? And so I'm going to take my table, you should take yours. Perhaps you might want to pause the video now while you look up your table value, and then we can check. So go ahead and pause now. All right, if you're back, let's see what I'm finding here. I'm in the 41 degrees of freedom row, right? Which is right there. That doesn't help you at all, but you're looking on your table. And we're in the 0.025 column, at the 41 degrees of freedom row. And my value I have on my table is 2.020. And so now we have all 4 pieces of the puzzle, x bar, t, s, and n. And so the rest of this is simply plug and chug. So we need x bar plus or minus t alpha over 2 times s over the square root of n. We've already computed our degrees of freedom. And so we have x bar is, what's my number, 86.5, plus or minus t we just computed, or we just found in the table, 2.020, times, standard deviation is given to be 12.6, n is given to be 42, we want the square root of that, 86.5, plus or minus, and the rest of this is straightforward mashing buttons on the calculator. So I have 2.020 multiplied by 12.6. I'm going to divide that by the square root of 42. And what I have is 3.927. The number of decimal places I'm not concerned with, but I'm going to use 3. Typically, if I ask you, I will specify how you would round. But 3.927 is what I have. If you round in a slightly different place on your computation, you might get a slightly different value, but it should be something approximate to this. And so that's our solution for that. This next I'm going to go through with maybe a little bit less commentary because I hope it should be straightforward. All right? So here, example number 2. How about this? How about you pause the video now, see if you can work through example 2, and then we'll check everybody to make sure we're all on the same page. So go ahead and pause now if you like. Okay, so now let's see what I have with my computation. Again, we need degrees of freedom, which is n minus 1, which in this case is 53 minus 1 is 52. We're in the 52 degrees of freedom row. Our value for alpha is 0.01. So that means alpha over 2 is the 0.005. This is 0.005. And we are in the 0.005 column. And we want the 52 degrees of freedom. 0.005 is here. 52 degree of freedom I have there. And I believe the number I'm looking for is 2.674. So our table value. I just said it and lost it. 52 degrees of freedom. 2.672. Let me double check that just to be sure here. 52 degrees of freedom. 0.5. 2.674. Good thing I checked. All right, 2.674. The rest of this is plug and chug. I've already written the formula, so I'm just going to substitute the values in. X bar is given to be 196, plus or minus, we just found 2.674 times S is, where's my number, 24.4, over the square root of 53. Notice, degrees of freedom to find the table value, but N in the formula. Degrees of freedom, 52 to find the table value, N, sample size is 53 in the actual formula. So make sure you use the correct number in the correct spot. We have 196 plus or minus, and then we're going to find another number. And let's see what I can compute out of that. See if I can get my machine functioning here. I have 2.674 times 24.2, and then I'm going to divide that by the square root of 53. And I end up with, well, goodness, that's 8.8887. I'm going to approximate that, 8.889. And that's my confidence interval, my 99% confidence interval. That's 196, plus or minus 8.889.